Hello, welcome. So in this video, I'm gonna do some Leetcode practice. So I'm gonna practice the first Leetcode easy problems. So there are still some challenges because some of the problem like number 14, I'm gonna use the prefix tree. I'm gonna use try. Yeah, and for others like number 28, I'm gonna use the z function. It may be also a challenge. Now let's get started. So let's start the first question. So I think the best way to solve the first question is to use a hash map. Yeah, we just need to enumerate the values in the nums and prepare a result should be equal to the target minus this way. So if a result inside the dictionary, we can directly return the result. So it will be the result. It would be an array. Inside, it would be a dictionary of result with the index. So otherwise, we just need to put the values and index as the key value pairs inside the dictionary. Now let me just run it and check if it works. Yeah, as you can see, it works. Now let's continue to solve the second question. And by the way, the first question is just ON time complexity. And the second question is a palindrome number. We just need to check a number if it is a palindrome. So for me, I would like to use a function. This is just to reverse a number. And I'm gonna prepare the function. So while this result should be result times 10 plus n modular 10, and then I'm gonna update this value of n divided by 10, and then I just need to return the result. So finally, I just need to check. So if x less than 0, I'm gonna return a false. Otherwise, I'm gonna return the reverse x if it is equal to x. Now let me just submit it to check if it works. As you can see, it works. Now let's just close this one and go to the third problem. Third problem is zooming to integer. We just need to prepare a dictionary to prepare the key value pairs. So inside it will be the capital, the Roman number with the normal number. So let's prepare a dictionary first. So I'm gonna prepare this kind of map, and here it's gonna be L to 50. Next it will be C to 100, and then let me just finish the map according to the description. So here I just need to use this kind of a map because basically inside my function I will do a special trick to save some kind of mapping key value pairs. So let me just prepare the result. Let me check. I just needed to return a number. So I'm gonna prepare a result as 0, and then I'm gonna enumerate. So I will start from the first one. So for I in range length of s, result should plus equal to my current number. It should be the s with d. It should be dsi. This is my number. Now I need to have a check if this dsi is more than dsi minus 1. I needed to do a trick. Because I plus 2 more, I needed to just minus 2 times my current my previous value. So it should be dsi minus 1. Finally, I just needed to return this result. Let me just run it. So something wrong, 56 and 58. So let me just check. It is a yes. Yeah, here I also need to have a check because if it is the first number, this I will make a mistake. I will compare with this last character, this I. The first character cannot compare with the last character. I have to have a check. So the I must be more than 0. Yeah, this is because here is I minus 1. So the I should be more than 0. It means I should be more than equal to 1. And then this is also valid as I minus 1. Now let me just run it and submit. As you can see, it passed. And so this time complexity is just ON. So this N is just dependent on the length of the string. Yeah. Now let me close this one and continue to the fourth problem. So for this problem, I'm gonna use the try. Yeah, if we are going to use a try, it's gonna be a medium problem. It should not be an easy problem because for easy problem, normally we don't use a try. It is a ON square basically. But for try, it is basically ON, and this N is just the length of the word. Yeah. So that is why try is so useful for solving such prefix problem. So I'm gonna prepare a try node. So inside of the try node, I'm gonna prepare the variables. So it will have a children. So self dot children. Yeah, these children will be dictionaries. Yeah, so the children will be a dictionary and self dot add of word because I needed to check if this is the add of the word or not. So from the beginning, it is just false for the initialization. And for this problem, I also need a insert. I just need to insert the word inside the try. So the insert is just inside the try class. So let me prepare a try class and prepare the initialization of the values. So basically for here, I just need to prepare a root. It would be the try node. Now I can prepare this insert. Yeah. For this insert, I can prepare a current node. It will be the self dot root. So here is self dot root, and here inside a class it would be self. So now I just need to check the word. So for say in word, if say not in current dot children, so I need to just prepare a new try node. So current dot children say should be equal to the try node. Yeah, if it already has, I just need to shift the current should be equal to current dot children with this character say. Now at the end, I just need to put the add of the word. So add of the word should be equal to true because I insert one at the end, it should be true. Yes, this is just preparation. Now I can just start coding for the main function. So for here, I just use a t to be the try. Now I can insert the word. So t dot insert with the word. Now I can prepare my result. It should be a string. So here I'm gonna prepare a current. It should be t dot root because I don't need to change the positions of the root. So I prepare a current variable. Now I can check while current dot children while it has children. So I can use a if check if length of current dot children more than 1 or current dot add of word. If it is add of word, I can break the while loop. So otherwise, I have a character say it must be only one character. I can list it. So list current dot children. So it must be the first, and it only has one character. So it is this say. Now my result can just plus this say. Now I can use I can shift the current to current dot children with this say. Finally, I just need to return the result. So this is a try solution. If we use try, it's gonna be a medium problem, I think. Yeah, as you can see, it passed. Now let me just submit it to check if it can pass all the testing cases. Now it passed all the testing cases. Now let me go to the fifth problem. So this is gonna be a stack problem. Basically, it is a valid processes check. Yeah, we are giving several processes inside of the string. We just need to check if this is valid processes. Yeah. So basically, if it is a processes, it must be a stack problem. So I have to wait for a while. Yeah. Now I can start coding. So I'm gonna prepare a stack for this empty array. Now I just need to check the characters inside of the string. So for say in S, I just need to use a if check. So the stack must exist because I will first check, if there is a open and if this character is close, I will do something. I will append basically. Otherwise, I will just pop. So if stack and here inside, I will prepare several processes because it will be a lot of things inside. I just need to prepare this stack -1 if it is equal to the open and say equal to close, and basically there's a or with another one. Let me just copy, and because copy can avoid mistakes. So for here, I just need to change this one to be the square processes. So here, I just copy the close to here. Now for here, I just need to use the bracket. I think this is called bracket processes. Yeah, so I prepared everything if it is a match. So basically, the stack just need to pop. Yeah, because it popped out of open. Yeah, if there is a close. Otherwise, the stack just needed to append the current character inside. Finally, we just need to check if it is not stack. If it is empty, we're gonna return a true. Now let me just run it to check if it works. It seems works. Now let me submit it to check. Yeah, as you can see, it works. And the time complexity is just O(n). It depended on the length of the string. And now let's just go to the sixth problem. The sixth problem, I think it is a merge two sorted list. So we are given two sorted list. We just need to merge them together. As you can see, it is not array. It is just the list data structure. Yeah, we are given two lists, and each of the list is sorted. Finally, we just need to return a new list, and the new list is also sorted. Yeah. Now let's just start the coding. For this kind of a problem, normally I'm gonna prepare a dummy node. So I'm gonna also use a pointer p as this dummy node. Because finally, I just need to return the dummy.next. Now inside, I need a tag while list1 and list2. So if list1 dot value less than list2 dot value, so this means I can put the p dot next should equal to a new list node. Inside it should be list1 dot value, and this list1 can be shifted to the next. So here is just list1. Else, so p dot next, it should be equal to the list node list2 dot next here, list2 dot value here. Yeah, and list2 should equal to list2 dot next. Finally, in outside of if else, we just need to shift this p should equal to p dot next. Yeah, if everything is okay, it goes out of the loop. So the p dot next should equal to list1 or list2, because we are not sure list1 exists or list2 exists, but it can be one or it can be none. Now let me just run it. Yeah, I think it works. Now let me just submit it to tag. Yeah, as you can see, it works. And the time complexity is just OM plus n. M is the length of list2. And now let's just go to the seventh problem. Seventh problem is to remove duplicates from sorted array. So this is basically a two-pointer problem. Exactly, it is a fast and slow pointer problem. Yes, because we just need to remove the duplicate in place. We cannot change the array data structure. We don't need to return anything actually, because we just need to change it in place. Yeah, so we are getting a sorted array. We just need to remove it. So the sorted array is very important to solve this problem. Otherwise, we have to sort the nums first and then try to solve it. Yeah, as I said, I'm gonna use the two pointers method. So J is basically the, yeah, let me think. J is basically the slow pointer. It means this will move very slowly, and I will be the fast pointer. So for I in range 1, because of the first number, we don't need to do anything. We're gonna start from the second number. So this means this is y. So the I will start from 1 to length of nums. Now we are going to check this I. So if nums I equal to its previous number, so yeah, if it's equal to the previous number, it means that there is a duplicate. So what should we do? We just need to update the nums j, because j is the position where we need to update, and j is the slow pointer. So nums j should be equal to the current nums I. Finally, the j should be, yeah, let me check. So for here, if It is like that. So inside this should be plus 2 1 to the next person. If we find a person, if it is equal, so we're gonna insert it. And C is the person where we need to insert, and we don't need to return anything. Now let me just run it. There's a mistake. Do I need to return anything or not? I need to return the K. Yeah, let me check. Maybe I need to return something. I'm not sure. Maybe I need to return this Z. Yeah, because it seems I need to return something. It told me to return the K. Here is 1 and 1. It should be 1 and 2. Yeah, let me check. Remove duplicate from sorted. This 1 and 1. Yeah, it should be not equal. If it is not equal, it means I've already found a number. If it is equal, it is not. It is still okay. If it is not equal, it means I already found a new number. So for example, this is 1 1. It's equal. It's okay. If it is not equal, I find a new number. So this new number should be inserted to the right place. The right place is number Z. As I think I need to delete this return. Basically, I don't need to return anything if it is in place. Yeah, let me end the return with this Z. Yeah, it seems I needed to return something. It told me to return this K. Yes, I need to return something. It told me to return this K. This K is also this Z. Now let me just submit it. Yeah, as you can see, it works. Now let's just go to the next question. Next question is remove element. So we are giving an array. Inside an array, there will be a duplicate. We just need to return the duplicate. So inside of the array, I think this array should also be sorted. Let's check the example. It's not sorted. We just need to remove the duplicate. So the duplicate removes the value. It's not duplicate. We are giving a value. We just need to remove the value, but it must be in place. Let's check if we need to return something or not. Yeah, we also need to return a value. So I'm gonna use 2 pointers to solve these problems, because basically I just need to check from the left side and the right side. So the L pointer and R pointer should be 0 and the length of the nums -1. So I can start checking. So while L less than or equal to R, I'm gonna check. So if the nums L, I'm check from the left side. Yeah. If nums L equal to val, yeah, if it is equal to the value, it means this number L must need should remove first, or it should be replaced with some other numbers. Yeah, basically I need to replace because this is the in place operation. So the nums L should replace with nums R. Here is also nums R with nums L. Else, if it is after replacement, so I'm sure at the right side it must be a 3. So for this example, yeah, it must be the value. So the R pointer should be -1. So else, if they are not equal, it means from the left side it is safe, so it should +1. So finally, I just need to return the left side. Now let me just run it. Yeah, it works. Now let me just submit it. By the way, this is a ON time complexity because we used the 2 pointers basically. Now let's just go to the next problem. So this is the nice problem. So this problem is a hard one. If we are using the start with in Python, it's gonna be easy, but that will be on plus on times m times complexity. It's basically n square. But we're gonna use better ways to solve this problem. There are some other ways like KMP, but for me, I prefer to use the Z function. Yeah, because I don't know how to use the KMP. Yeah, basically I don't remember it. Even I understand it, but yeah, I can't remember it every time while using the KMP. So for this one, I'm gonna use the Z function. Yeah, I'm not sure I can write this Z function, but let's just try. So Z function is basically inside it is a string, and while we need to do some preparations for the Z function, so I'm gonna prepare this S. So the S should be the needle plus a special character which is not appeared in haystack or in needle. This is very important, and this is also the basic pattern to solve the string matching problem, no matter it is a Z function or it is a KMP. Yeah, basically now we can prepare the Z array should be equal to Z function S. We can put it inside. Now we just need to check the Z array. So inside of the Z array for in enumerate the Z array. I just need to check if this n equal to the length of the needle. If it is equal, it means I've already found. I just need to return I minus length of the needle and minus 1. Because we also included a hash, we just need to minus that hash. Otherwise, if we didn't find, we just need to return a minus 1. Now let's go to the hard part. So basically from here is just about how to use this Z function. The hard part is about how to write this Z function. Basically we need to prepare a Z array and left and right pointer. This left and right pointer is called Z box. We're gonna use the Z box to solve the Z function. Before that, I also need to prepare a variable. It would be n, should be length of the string. Now for the Z function, because the first one, I'm gonna always use 0 times the n as the Z array, and the left side and the right side from the beginning, the Z box is just 0 and 0, and this right side is just and this left side is just with close, and this right side is just open. It means this right side is not included, and this left side, this 0 is included. So this is the definition of this Z box. Now I'm going to check for the string. So for say in range, I'm gonna start from the 1 because the first one, the Z0, it should be 0. This is also the definition of this Z function. This is easier to calculate. So the first one will always be 0 because there's no matching. After the first character, there will be matching. So that is why I start from the index 1. Now I needed to check. So basically there will be if check if the I let me think I will use the index I for I in range 1 to n. So if this I less than the border from the right side, so the Z box have a left side and a right side. Basically this I, if it is less than the right side, we're gonna update the Z array. So zi should be the minimum of r minus I with this z I minus L. This part is basically for saving the time by using the Z box. The R minus 1 is basically because if it is this Z minus L, if it is already out of the boundary, so it have to choose the smaller value. This R minus 1, it must be smaller. Yeah, otherwise, if just choose this one, actually, yeah, let me give you an example maybe. If we attack a string, maybe a something. If this is the last character, this a from here, if this is the last character, we just need to compare the minimum because this one, the I minus L may be bigger, but this one R minus I must be 1. It means it will choose the minimum. Now I need to use a while tag. This while tag is basically like the brute force. So I plus zi if it is less than n and the z, yeah, let me check. It should be the string should be zi if it is equal to, we're gonna use the z box. So for here it would be zi I plus zi. Let me put the I first. Yeah. So for here we just update the zi by 1. We just count at each prison how many, yes, same characters. So this z function is actually the subarray, which is equal to the prefix. Yeah, if this subarray, yeah, is equal to the prefix, we're gonna count how many of them. Now there's another check. Check this I plus zi. So if it is more than r, it means it is out of the boundary. It's out of the z box. We're gonna update the left and right pointer to be I and I plus zi. So this is basically the z function. Finally, I just needed to return this z array. Yeah, as you can see, there's not so much code, but it's really difficult to understand why each step will be like this. I'm not sure, just to check. Yeah, just to check if it works. Yeah, it seems it works. Now let me just submit it to check if it can pass all the testing cases. Yeah, as you can see, it passed all the testing cases, and it's pretty fast because this is just O(n) time complexity compared with O m times n. Basically, yeah, it is O m plus n because the S string is needle plus the haystack. Yeah. If you don't understand this z function, it is still okay. You can just copy and paste this kind of code first, and then try to use it first. After you use it for a while, maybe you are interested in how to write the z function and what is the basics, why the z function is like this. Yeah, by understanding the z function, maybe it's easier to understand KMP. Now let me just go to the next question. The next question is to search the insert position. Basically, this is a binary search problem because we are giving a sorted array. So inside the sorted array, we just need to find the target value. If we didn't find, we just need to find the insert position. So for this example, we already find it is 2. And for the target 2, it's not inside, but we're gonna insert it at the right position. It should be 1. Now I think it's ready to code. Now let me prepare the template for my binary search function. So this one would be the same. But for here, I prefer to use less than equal. Maybe everyone has his own different template. Yeah. So the m should be L plus R minus L divided by 2 So if nums m less than the target, it means yeah, it is current value is too small. If it is too small, so the left pointer should be equal to m plus 1. If nums m is more than the target, if it is too big, so the right index should be m minus 1. Else it means equal. We need to return the index m. Otherwise, we just need to return this left pointer. Now let me just run it. Yeah, it seems works. Now let me just submit it to Tag. So by the way, the binary search is always a log n time complexity because we always take the values by half for each of the tag. As you can see, it passed. Yes, thank you for watching. So this is basically the practice of first 10 Leetcode problems. So for each of the problem, actually I used the best ways to solve it. Maybe some of them may be hard, log common prefix. If you're gonna use the try, it's a good practice to use the try data structure because it's difficult than a train. And for this one, 28, it is I used the z function. Yeah, so z function is also a hard one to understand. It may take the time to understand the z function. If you don't understand, it's okay. You can just copy the template code and try to use it because it's easy to use. Yeah, thank you for watching. See you next time.